3.4. Discuss the energy losses that occur as energy is fed through the transmission line of or from the generator to consumer. So power stations are connected by cables to all uses of electrical energy, whether that be personal, industrial, commercial. The generator at a power station produces three-phase alternating current at a voltage of 20,000 volts for transmission. So the actual power or energy supplied per second is given by the equation P equals VI. Now we know that some of the power or energy being fed into the transmission line is wasted before it reaches the consumer because 20,000 volts is not safe for the consumer. So most of it is lost as heat developed in the transmission wires, which if they have a resistive R ohms is given by the equation P equals I squared R. So this is referred to as heat loss. Now if we're looking at the power loss, we need to keep both I and R as low as possible to not affect P, which is our power. Now to counteract that, we use thick wires when we're looking at resistance because it is inversely proportional to the cross-sectional area. We also look at aluminium alloys or conductors, which are used for power transmission cables because they are cheaper, lighter than copper. To increase the strength of the conductors, the aluminium strands are wound around a galvanized steel wires. To keep the current as small as possible, given to the practical the size of conductors, it is necessary to use high voltage or high push. The highest voltage used for the transmission of electricity in Australia is 500,000 volts or 500 kilovolts. Transmission lines carry extremely large voltages, and so care must be taken for that electricity and does not travel down the supporting structure into the ground. So disc-shaped glass or ceramic insulators can be seen at most power poles separating the wires from the pole. The greater the voltage being carried, the more insulation is required.